Okay, in this lecture I will talk about tracking objects in fluid simulation. And to do this, we need to use a wave tank, which is placed on OceanFX tab. But first we need to create the model to be tracked. So to do this, I will use the prepared model boat. And to place it in the scene, I will create a geometry tab and dive inside, and in file I will choose my boat, my model, fishing boat, and this one is really huge in scale, so I will place a transform node, make it 10 times smaller. Okay, and also I see that there is little problems with normals, so I will place a facet node and post compute and cusp. So now normals are fine. Okay, this is my model, and to make it trackable, I need to assign it to a wave tank. But for a more interesting effect, I will do a simple simulation first. And to do this, I need to create a null and use it as a parent object for boat. Let's call it boat. Like this, and boat parent. Okay, and connect it like this. It means that boat will be a child for my null. Okay, now let's make a simple animation. So I create a keyframe on frame 1. So I right mouse button click, channels and keyframes, set keyframe. Okay, now let's move to frame 50, for example, and do a little translation and set a new keyframe. Okay, so now I have animation. Okay, now it's time to create a wave tank, and to do this I select nothing, and then I click on the shelf tool, wave tank, and here underneath you can see that it's asked me about select objects which should be tracked, and I click on my boat and hit enter. So I need to wait a bit, and now you see that I have a fluid tank and boat. Now if I will play the animation, okay, first I will decrease the resolution of the liquid to make it calculate faster, and I do it in Autodesk Network. It's should be very familiar setup for you. So dynamic object, static object boat, wave tank, particle velocity. So this field is updating velocity of each particle, and sourcing from wave tank and boundaries. Okay, and flip solver, gravity, that's all. So I select a wave tank, and now you see that particle separation is really huge. Well, this is a dynamic value, so when Houdini creates a wave tank, it automatically calculates suitable particle separation. So I will set it to 3, for example, so particles are way bigger, and we'll play animation now. So you see the color of the particles are changing. It means that velocity of these particles are changing too. And here you can see the little dots. This is a splash particles or white water. Okay, so now the boat is moving, and it creates little waves here. Well, it's hard to see, so I will bring it back to number 2 and play it. So yeah, it's just slicing the water Okay, and the simulation is not limited by this box. So for example, if I keep playing the animation, you can see that boundaries of this box is changing. So the size of this box is always constant. Okay, there is a lot of different parameters which is controlling the behavior of this tank. And in tank initial, we have ocean spectrum, ocean preview, this is standard, wave tank, which is which has boundary level. So if I select the wave tank and switch into boundary level tab, I can visualize my boundary. And now you can see the green color. So like this. And this is newly fresh particles. Okay, turn it off. Also, I have lower padding and upper padding. This controls the amount of padding from initial size. So you see like this, or on this side. So for example, if my animation moves really fast in one of the directions, let's say something like this, so the boat will move on that direction, like so. The more padding will be necessary on this direction to avoid disappearing of particles or something like this. Okay, so let's make the simple animation in that manner and set new keyframe on rotate Y, because the boat must rotate in the Y-axis, like so. Okay, and frame 50, and let's say the boat turns on 90 degrees. Okay, I will turn off the simulation for a moment with little this brain button. So once you click it, it will stop to simulate the liquid. Okay, frame 50, and let's say this is 90 degrees turn. Commit change to set a new keyframe. Okay, go back, activate the brain or calculations of simulation, and let's play the simulation. So now you see the boat is turning, and I don't need so much padding on this side. Well, the rear part of the boat is coming here, but oh, probably no, it should be correct. Okay, let's see. Okay. Looks like that animation, the tracking happens only in translation. So when I do a rotation, it doesn't work. So okay, to solve this problem, you need to increase the size of the fluid tank. So let's say X, Y, Z. I need to make it bigger on Z axis. Let's say 100. Okay, great. So now I can make a turn without any problem. Again, all the simulations are really flexible, and you always need to try different parameters to get the best result. So, okay. Here, another problem. Well, too much velocity on this side, and liquid is coming on the boat. Well, this is like this happens in reality, but probably the turn is too fast. Well, to avoid this or minimize, I need to increase the amount of substeps in Autodoc network, and it has substep here. So if I set 2, it will increase calculation time twice, because for each frame Houdini need to do twice more simulations, but this will bring us to more accurate behavior of the liquid. So now you see that particles here is colliding with both, but their behavior is not that strong. Again, this is a simulation, so objects are colliding to each other, and you need to check your collision geometry. And to do this, you need to go to Autodoc, select your boat, turn off display geometry so we don't see the boat, and turn on collision geometry in collision step. Okay, show collision geometry, and now you can see why the water coming through side of the boat. It's because there is basically no collision. Okay, you see that resolution of the collision geometry is really low. To improve it, I would change division method in volume here, and in both collisions volume, I would change division method into by size. This will make all the parts equal in size, and now it calculates because the resolution will be really high by default. So I need to wait a bit. Okay, 0.1 was too small, so the calculation was incorrect, and 0.3 gives me that, which is too small also, and brings me to a lot of artifacts. I'll set 0.5, and okay, that's give me a nice result. And there is few parameters which we can try to activate to get a better result. First, laser scan, and this basically a bit different algorithm. Okay, let's give me this, which is not correct, so I turn this off. And 0.5 looks like too much still, even though little parts here are missing. Well, again, the model, the sides on the front of the boat is really thin, so this can be a problem for calculation of collision geometry. So I will set 0.6. Okay, the sides are disappear almost. And here you can play with offset surface. For example, it's like increasing the surface a bit, collision. So you see it gives me little details. The accuracy is a bit decreased when I do this, but again, it allows me to get small details. Okay, now it's almost perfect. I'm really happy about it. I'm missing the part here, which is tiny ropes. Well, it also depends on how accurate your simulation should be, but I guess for most cases nobody cares about tiny rope. But most importantly, we have this. So okay, let's turn off collision geometry, and I will play animation one more time, just to see how it works now. Well, particles are still coming through. This can be because of low resolution of the liquid and sub-steps amount, because I change it. Okay, it stands like 2. Well, if I set, for example, 5, the calculation will be really slow. But let's see how it looks. That's okay. Okay, let's play. My suggestion is that even if it's not helping now to increase the amount of substeps, then I need to decrease amount of I need to decrease the resolution of the liquid. But this will be too heavy for calculations, because it's pretty common to wait from 2-3 minutes per frame up to a few hours per frame. Depends on your machine, your resolution of the liquid, and so on. But yeah, it will be long. But okay, you see now that liquid colliding way better. It's still coming through, but this looks like the resolution. Okay, and this is particles generated like a white water or air bubbles. Okay, let's turn off, let's decrease amount of substeps back to 1. Oh, and there is a checkbox which I turned off and didn't tell you about it. Haven't told you about it. Cache simulation. Once this checkbox is activated by default, it will create a cache for you, and sometimes it's really important to have it turned on. But from other side, it takes too much memory, and if you really tight on memory, then just turn it off, and it should do it. Okay. So resolution back to 3. All right, and turn on display, turn on guide geometry. All right, this is a boat behavior. What do we have more? There is a white water sim wave tank initial, which I've been talking a bit about. Okay, and surface evaluation in wave tank, ocean flat. Okay, we have particles, which are controlling the water level. Okay, surface. It's visualizing the surface. Like this. Okay, velocity. You can control the velocity field of the liquid. So if I activate this and set direction to any value, and play now. Velocity. Probably this controlling the waves. Maybe it will work on lower resolution, on the higher resolution. But this basically creates velocity. Sync objects, I will tell you about it a bit later. Okay, and boundary level. All right. There is different waves, types of tank. If I set to splash tank, it will behave a bit different, like there is no depth. Okay, wave layer tank, flat tank. The flat tank is probably has no waves. so just like static water. The beach tank. Well, it's tanks with different presets. Okay, let's go back to wave tank. Okay, and here you have file cache, so you can cache out the behavior of this of the simulation. Okay, wave tank, flat interior, whitewater. This one is simulating the foam, spray, bubbles, and so on, and you can visualize it. So once you come into whitewater sim, and this icon is just showing that this is a simulation node. So whitewater sim, come inside, and this looks almost like an Autodoc network. Okay, but let's select whitewater object 1, and here you have create from specified simulation frame, so you can set which frame the particles will appear. Okay, and in guides you can activate color particles by type, and now you can see different types of particles which were generated like this. So all of them are here. I can visualize surface and velocity. Velocity is visualized by these lines, and surface you can see here. Okay, so now you see that surface is not really nice because of low resolution, and particles is coming way too much. So if I render, for example, this will look like this, which is not nice. Okay. Whitewater emitter, you can control particle behavior, impulse count, birth rate. I will cover the particles in next lectures. So now we can just try these parameters by itself. But again, the names of these parameters are really self-talking, so self-explaining, so it shouldn't be a problem. So you see, I increased the amount of constant birth rate, and I got way too much, way more particles. Okay, fine. Let's bring it back. Life expectancy is how long the particles will live in seconds. So if I set 1, and life variance is the difference for life particles life. So it's also in seconds. So when its life expectancy is small, the variance will be hard to see. But I will play animation now. And on frame 24, particles should start disappearing. Yeah, kind of here. Okay. Whitewater solver. Here you can control the parameters of the foam and behavior. Preserve foam. Currently I have no foam attribute, or I'm not sure. Yeah, there is no foam attribute now. Okay, behavior spray. So there is a bunch of parameters. Here is a buoyancy force for bubbles. So buoyancy is just lifting force. I will show the example on this lecture. Okay, and all of this you can control here, but this is kind of advanced stuff, and to get all of this, you really need to spend way more time to by playing this. Okay, so this is basics of the object tracking. So you don't have to create a full-scale ocean to make a nice boat or something like this. It's enough to have just tiny splash tank. Okay. Next thing is buoyancy force. I will create a new scene. And buoyancy force is a bit tricky in Houdini because it's really hard to find the proper force scale. But I will show the conception, and later you can try it by yourself. But probably it will work now. So I will create a tank to hold my water like this, or basically I can create particle fluid flip tank like this, and the ground, so my active object will not fall through it. So like this, I will turn off the grid, and now I need to create any object. Well, so let's say the box here, like so, and now I need to create. Now I need to make him active. So let's click RBD object while cube is selected, and play animation. So yeah, now it's falling, and you see it's inside of water. Okay, fine. Now let's connect buoyancy force. To do this, you need to go to Auto.network, and here is our standard setup. Okay, to add buoyancy force, you need to create a buoyancy node. Type buoyancy. Forces. Okay, it's a difficult name. Okay, buoyancy force. And it's necessary to connect it after the gravity, like this. Currently it will do nothing because it's necessary to connect data to attach. Okay, to connect some data, we need to create a fetch node, fetch data, like this. And here you have to fill this field to tell the Houdini which data you want to take. Okay, to figure out which data you want, let's go to Details View and open our flip tank. And here you see the bunch of parameters, and we are interested in surface. Once we will grab data from surface. Okay, so what do we have here? In fetch data, we have source object, which is our flip tank. Okay, yes, this is flip tank. So let's type a flip tank here. Flip tank. In source data name, we need to type our field name, surface. Okay. In data name, you can type anything you want. This can be used later for visualization or something else. Okay, and now let's play the animation. Oh, and I forgot to connect the fetch data to buoyancy and change the flow. Okay, now it should look like this. And nothing happens. Well, that's because force size is 0 in all of them. And I will start in y-axis in size 200, for example. I really can't tell which numbers I want to use. And you see that all my water is just lifted up, and that's all. Well, buoyancy force is working. At least it's working. Okay, to avoid this situation, in buoyancy force, we have a group tab, not tab, but group field, and it stands a wildcard. It means that force will be applied to any object which is fitted into it. To exclude some object, we need to type this sign. I don't know how it's called, but this sign, this is like a standard exclude sign, and select our fluid, flip tank. And by default, it creates a space here. You need to delete it like this. So now if I play the animation, you see that water is staying on the place and cube is still falling down. Okay, now we need to create a force which will lift the cube. So now you see that cube behavior is different. Now it's falling up and down in liquid, but behavior is really unnatural. So 6,000 is too much. So I will set 2,000, for example. It's really hard to tell which numbers you need. Okay, and it stands on the ground. It's basically test and fails. Okay, but you can see that behavior of the cube is really changing. What else you can do? This is my suggestion, I'm not sure, but in box we have a physical tab and we have density and mass. I will change the turn off compute mass and set it just static mass. And okay, now the force is too huge, so I will increase the I will set mass to 1, and the buoyancy force I will decrease it. So, okay, I changed the values, and now you see that force of 29 is easily lifting up and down the cube of weighting, which is weighing 1 kilo. So let's decrease it 3 times. And it's still too much, but behavior is better. So force is 3. Actually, when I was working with this force, I found that the proportion is around 1 to 4. I mean, 1 kilo of weight is force 4, and you see it's working really nice. Maybe, yeah, maybe too much, but it's changing into really something really tiny numbers. And last time when I was working about my Jack Daniel, I spent really a lot of time to find the proper force. Maybe there is some workarounds which will give a better result in shorter time, but that's how I work with. So 3.7 is too much. 3.2. Okay, it's stuck on the ground. When I'm working with such numbers, when I'm playing this game, find the number. Normally I'm doing this. If, for example, value of 3 is really small and value of 4 is too big, then probably I need to try a value of 3.5. And it's too much. Yeah. Okay, one thing we can try is add some viscosity and density to the liquid. And you can do it in physical tab. So let's say viscosity is really small, something like this. And don't forget to turn on viscosity in the solver, like so. So now you see that cube behavior is smoother, but still the lifting force is too big. Okay, and turn on density to see how it works. Okay, now the lifting force, well, it feels like plastic. So yeah, as I told, it's really tricky to make it work. But you get the idea, and you just need to find the number. Yeah. So maybe I need to increase the weight of the cube. Yeah, so you basically need to find a balance between mass and lifting force. And once you finish this task, this will give you a really nice result. There is another option to make objects to float on the surface, and you can find it in Flip Solver. I have a little error here. Density field. Okay, it's not happy about my density. Okay, in Flip Solver, in Solver tab, there is a feedback scale and mass scale and spatial scale, which is telling the scale of simulation. Okay, by default it's set to meters. So, and the default measurement of the Houdini scene is meters also. So, spatial scale should be in 1, basically. Okay, but I can increase the feedback scale like this. So you see what it gives to us. The box start jumping on liquid. So this should be a really tiny number too. All right. Bounce. Yeah, okay. So I made the cube a bit lighter, and you see it's trying to lift up. So maybe I need to decrease it like 100 grams or so. Yeah, so you see it's trying to lift. The numbers are almost here. And now you see that mathematic, it was almost working. So really tricky, really. Okay, this was a buoyancy force. Next thing I want to tell you about is sink from object. Let's use the same scene here. So I have a cube, I have water, and to make this liquid disappear when the box is coming inside of this tank, to make it work, I need to go to Particle Fluid tab, and here I have Sink from Object. Okay, to make it work, select nothing, and click on Sink from Object, and now it asks me about select the object. Okay, I select my box and hit Enter. Now it's asking me about fluid. I'm diving inside Autodop network and select a flip tank and hit enter. And it converts my cube into volume, and you can see that it's volume because you can see voxels. Okay, and to control the resolution of this cube, because it can be not a cube but any character or any hard surface object with some complicated shape, you can decrease the vision size from 0.1 to 0.05 like this, and it will make the voxel size smaller, and you will have a lot more voxels. The smaller voxel, the more accurate details are. So here you see that I have a nice round corners, but if I bring it back to 0.1 to default, you can see that I have an artifact here and the shape is not really followed. Okay, now let's play the animation and see what will happen. Okay, and that's strange. For some reason, nothing happens, which is strange. Okay, let's create a new scene. Absolutely new scene. Okay, and create ground plane. Create a flip tank. Flip tank. Okay, and okay, I don't need the ground. I need the flip tank. And create a box. So box. And again, to do the animation, I need to create a null object, parent it, and let's do animation for null. But first, let's offset it to the side like this. And let's say first keyframe. Move it here. Set the new keyframe. Okay, let's play the animation. Okay, I will create a brand new scene. Flip tank box. No. Alright, now I have animation like this, and now I need to convert my box into sync object. Okay, it's converted. So now I play the animation, and you see that liquid is start to sinking in, and the amount of liquid is decreasing. Okay, to make it more visible, I will put the box a bit lower, like this. And you see that liquid is just disappearing. It's like a draining, the box is draining the liquid. There is a way to drain more liquid per second. And to do this, you need to go to Autodop network, and in flip solver there is a time scale parameter. So if I set it to 5, for example, and play the animation, you see that amount of liquid which is drained is way more. But the side effect of this is that liquid behavior by itself will be speeded up 5 times. So if, for example, you have nice waves in tank, you will have them 5 times more and 5 times faster. So like this. And this is draining from object. Okay, that's basically all what I want to tell you about ocean and water effects. Thank you for watching.